Good morning, all. In the next 10 minutes, I'm supposed to teach you statistics, which I'll not be able to do, but I'll be able to show you how not to be afraid about statistics. Greetings from AIMS Jodhpur. I'm going to talk about biostatistics for beginners. So as Prabodh started, he said, like, why me? Like, the subject of statistics for most of us, like me also before, was like it was the concept of Madagascar for zebra in the movie Madagascar, if you know. So why we need to know as surgeons about statistics is it's evidence-based medicine, writing dissertations, communication with a statistician, understanding a research paper, and doing your own research. Start with the simplest concept in statistics. We all know variables. Variables are divided into numeric and categorical. They are continuous, which is height and weight, discrete, which is the number of people in a room like this in the hall. In categorical, they are nominal, when we can categorize them as male, female, child, adult. Ordinal, when we can grade them from mild, moderate, severe. The simplest concept we all know is percentages, and is the easiest way to calculate. But we all should be aware that we should know the actual number of cases by anyone, because authors can use percentages to hide the true size of data. Like I might say that I have 0 complications. I have done 1 case and there is no complication. That doesn't mean. So the numbers are important rather than when we talk about percentages. So we need to keenly see this in our statistical data. The next thing we know is distribution. All the papers will keep quoting about normal distribution. What is normal distribution? Normal distribution means it was given by a person called as Gauss, who is the German mathematician. This means the data is normal distributed on both sides. Simplest concept again, mean. A lot of papers will tell you about mean. It should be used in normally distributed data, and mean is actually the average of all the values in the data. We need to check for outliers when we talk about mean, because outliers can skew your data and you cannot use some statistical test during doing this. So always look for the outliers, make sure it is not entered in your data, and you should delete the outliers from your analysis. If you cannot use mean, we can use median. Median is the point at which half values are above and half values are below. In this thing, we don't use standard deviation, we use interquartile range. And the rarely used thing is mode, which is the most common set of events which are frequently appearing in a value. Like we know about the rhabdomyosarcoma, which has a bimodal distribution age-wise, infancy first and then during teenage. Standard deviation we all have heard about. It is normal in a normal distributed data. It is a quantity expressing about how much number of members of a group differ from mean value for the group. Now, very interesting concept again, confidence interval. Confidence interval is a range that is likely to contain the true population value, and statisticians calculate this range in which the true values lies. It's very difficult to understand what is true value, but I'm trying to simplify in the next few slides. So suppose you have a set of these people, a population. The mean systolic BP of this population is 170. Now you found a magic pill, and blah, you are able to reduce their BP by 20 millimeter by using this pill. And the confidence interval derived by a statistician is 95% confidence is 15 to 25. What this means exactly is that you can be 95% sure that this drug was able to decrease the actual BP by 15 to 25% of systolic BP. This is as simple as this is. Another example, you have another group, you use some other drug, the BP again falls by 20. But the confidence interval here is -5 to +45. The confidence interval here includes the value 0, which means no change. So even if the calculation is showing that the BP is decreasing in this set of population also by 20, but the confidence interval here is showing that it is actually, there is -5, it is actually increasing the BP in some number of patients. So you should see this confidence interval while seeing the data. Coming to p-value, we all know what is p-value. I had to little bit rush because the time is quite less. Coming to null hypothesis, we all like when we start our thesis, we write our thesis, we come to null hypothesis. So what is null hypothesis? Simply I am going to show. Suppose I say all Schwanns are white. How I am going to prove this? I show more white Schwanns. Can I prove it like this? So to disprove this, I'll show one black swan. This is easy, like this is what is null hypothesis. So you have to actually nullify what the hypothesis is. So this is a famous quote by Einstein is no amount of experimentation can prove me right, but a single experiment can prove me wrong. So this is the p-value. We know that p-value 0.5 means there is a statistical significance. This means that if an event has happened between the two sets of people, it is by chance it has happened in only 1 in 20. If it is 0.1, it has happened only 1 in 100, and if it is highly significant, like it is 0.001, it has happened by chance only in like 1 in 1,000 times. T-test, we know T-test is for comparison of means. It is paired, unpaired. I'm going to show you a very simple way of doing a t-test. So suppose you have like 100 individuals, you divide them in this group, and then you have 50 men, 50 women. You are trying to see the average height comparison between men and women. This is a very easy formula. You can put it and do the calculations. Very easy, right? No, we don't do t-tests like this. I'm going to show you the easiest method. Just relax, have a coffee or drink of your choice depending on the time of the day. Google it, do online t-tests. The basic software, the basic site which will take you is the GraphPad Insight, is my favorite software to do statistics. Just put your data in that column, click do t-test. It will choose a t-test, it will give you the results, it will give you the graph. Very easy. Surgeons can do it, everyone can do it. If the data is skewed, not normally distributed, do Mann-Whitney test and other non-parametric test. Chi-square test, same thing. It is to compare the proportions. You can again go to the GraphPad Insight website and do it. It's very easy again. This is one example. I have to just run. This is risk ratio, only 3 minutes. So risk is the probability that an event will happen, and risk is calculated by dividing the number of events by number of people at risk. I will share these slides with all of you. This is very easy. These are used in basic surgical theses and all and other studies we do. So if risk ratio is more than 1, that the rate of event is increased compared to controls. If it is less than 1, the event is actually reduced. This is the formula. Odds ratio we all know. This is another example of odds ratio. It is calculated by dividing the number of times an event has happened by the number of times it does not happen. This all we are learning from community medicine. We have to use this. It's again very easy to calculate. Can be done online. No need to use fancy softwares. This is one example of it. Correlation we hear in a lot of studies. Correlation is a strength of relationship given by correlation ratio. It can be from -1, where is negative, proper negative correlation, and +1 is perfect, positive correlation. So this is R values which you get when we talk about correlation ratios. If it is very high from 0.8 to 0.1, which is impossible in scientific data, you should check for errors and data is not properly. If someone is saying their correlation is more than 9, it's like saying that the sun is rising from the east, that too on planet Earth. Okay, so you have to check if someone is quoting very high correlation ratio. So this is example of positive correlation, example of negative correlation. And also remember, correlation does not mean causation. So if the size of my beard is more like I'm a very good was a smart person, no, it doesn't go in that way. Regression is the same thing. I'll skip few of these things because the time is less. Most important last few slides which I'm going to spend time is how to enter data. We give really bad Excel sheets to a statistician and they have to really work hard in cleaning or repairing those Excel sheets. So most important thing for us as a surgeon is at least enter your data properly so that your statistician has to do less work in cleaning your data. You have to put your data in a machine readable format because softwares recognize data as numbers and alphabets only. So remember that only number can be analyzed. A should be put as 5 and not 5 years. Maintain the same unit, don't keep changing it. And assign a number to every categorical variable like 0, 1, 2. Put separate rows for individual patients, separate column for each variable. Never include variable in rows. And don't leave empty spaces because the software will read it as 0. Another example of the same, you should have a code book when you start your study and all data should be coded before you enter them in the Excel sheets. And if you do this, you will have a very nice, beautiful Excel sheet. How to talk to a statistician? It is needed for just 2 slides. Planning a study, when you plan the study, you should talk a proposal, all the stages you should keep meeting the statistician. Same thing, if you talk with a statistician from the beginning of the study, your study will come out very well. There are very, very easy softwares free of cost available, and you can use this online as well. So keep calm, do your own statistics. It's not very difficult, it's doable. Thank you.
Thank you, Dr. Kirti Rathod, for finishing within the stipulated time. It was, in fact, a very simplified introduction to biostatistics for the beginners, because biostatistics is something that the beginners are really afraid to delve into. If there are any questions from the audience?
Actually, it's very difficult to provide the information required in the time allowed. So it's a very vast topics. We could have full day workshops and conferences on each of the 2 topics we started in the morning. So, but the importance of biostatistics, as Dr. Kirti has just introduced to us, is that even NMC mandates that every faculty member and resident, PG resident, has to complete the basic course in biomedical research before they are granted the service or promotion. So I think we all can take a cue, get started now, even if not done till now, and go on with our knowledge base improvement. Thank you.
Thank you.
Thank you very much, Kirti.
Thank you, sir.